Hi, in this video I'm going to give you a complete and total beginner's introduction to R software, starting from how to install and set it up, and how to orient yourself in the GUI, how to use it. What I'm going to do is I'm going to show you how to use R through the GUI called RStudio. RStudio just makes using R a little bit nicer and easier. It's very commonly used. What you'll need to do to get started is you'll need to go to this particular spot up here in order to download RStudio, and it also gives you a link for downloading and installing R from that same spot. You can also download just R by coming over to this spot, cran.r-project.org. It's kind of the center for all things R, and from there you can pick your particular operating system and download it from there. And then again, as I said, install RStudio. Once you've installed both of those, when you open RStudio, it will automatically open R within it. So you only from then on need to open RStudio. Find RStudio on your computer, click on it, and open it. That's all you need to do. You don't need to worry about R. It pulls R in on its own. And this is what it looks like. This is RStudio here, and this is the interface within R itself. If you were to just open R directly, it would look really similar to this. This is the R console. Okay, now there's a variety of windows and tabs and so forth. I'm just going to show you the ones that are useful to people who are getting started, not the really advanced things. Okay, the first thing to be aware of is we have this console here, and in the console, right at that little caret, you can type an actual command or R code, have it do things, okay? Just from that little caret there. For example, you can do basic arithmetic. 2 plus, let me click there, 2 plus 3, hit enter, gives you 5, of course, right? And there'll be things that you'll learn with time, different functions they're called, which are basically things where you put an input into a parentheses and you get an output. And for example, that's a log, gives you a logarithm of 3. You can do use an asterisk for multiplication. You use, let me find the caret, it's above the 6. Oops, I'm going to do a 5. Caret squared for raising it to a power. Okay, that's some of the basic things that you'll need to know how to do. Square root would just be written like that, and so forth. Okay, so those are some of the basic features. For division, you just will use a slash. Okay, and so that's your basic arithmetic that you can just do here in R. And of course, you probably wouldn't use R just for that, but you can do that within R, and you can use parentheses to make it quite complex if you want. So that is your basic introduction of using the console or interface. Well, most people don't type code in there directly. You can, but you don't need to. There's better ways to do it, and one is to open an R script file. So I'm going to next show you how to do that. If you come up above here where it says File, on that drop down, go to New File and click on R script. Okay, what that does is opens this editor here, interface, where you can type in R code. You can write a whole program, you can just write one line of code, whatever you want, and run it from there. Essentially, when you type things in here, you run it from here, it just pops it down below and runs it down in that console for you. So I could just, do a math problem here, and if I have my cursor on a line of code and click this run button, it's just going to run that line. Okay, if I want to run a whole bunch, then what I need to do, like a whole bunch of lines, I can highlight and run all of those lines at once. Okay, so just click on run, and you'll see it popped it down below and gave you the answer. And I can just pick and choose whatever I want to do here. Okay, and of course this is really simplistic. Now if my cursor's on that line, it just runs that line. But if I highlight a section of code, it'll run that entire section, so both lines of code. And you save it here. Okay, so that's something to be aware of. You generally want to save it. Although, when you close out of RStudio, it typically now when you reopen it, will reopen whatever you had here as your R script immediately. But always save it, of course, just to be safe, and because you may not be, reopening it it may not be the first thing you go to reopen. So that's what we do, and hit save. Now, as far as where you want to save it, you can hit save, and then I can navigate to wherever I want to be to save it. Okay, whatever subdirectory I want, just like you would normally save things. Another thing that you can do is you can, under session, choose a working directory. Now, if you choose a working directory, then it'll go there automatically as the first choice of a place to save it. So that's often a very useful thing to do. It's going to be really necessary when you're reading in files or saving files to have set the working directory where all the files are saved that you are either saving or drawing from, okay? If you have already saved your script file, you can just click on to source file location, and it will automatically save it there. Otherwise, you can choose a directory where you want to be. So let's just say that I want to be just here in I'm going to make a new folder here within my documents folder. Okay, I'm just going to put it there, and it saves it. Now what you're going to see down below when you do that is the command that was run. The command that was run is this set working directory command. I will often, once I've set a working directory, copy and paste that entire line of command up here into my script file. The reason that I'll do that is because when I come back to this project, whatever I'm programming here for, and I'll usually put it as the first line, I'm going to take those out. When I come back to this project, every time you close and reopen R, you have to reset your working directory. That way I don't have to go through the drop-downs and find it. Maybe I don't remember what the working directory was, and I don't have to type in this entire line of code, which of course would be a real nuisance, and there'd be a big chance of typos and typing that whole thing in. So I will typically, as my first line in any R script file, which is basically one R program to do things, put this set working directory command. And the way I get it is by the first time, again, going to session, set working directory, and generally choose directory and navigating to the one that I want. Okay, so now I've got that set up. So that's one of the first things to be aware, one of the first things you can do here in this script file. Okay, now one of the other key things that I want to tell you about as you're putting commands into a script file is you use the pound symbol for commenting. So you can type whatever you want, and whatever comes after that pound sign will be commented out, meaning it doesn't think it's code. It doesn't try to run it and give you an error. You can just write things as long a text as you want, so long as you've got that pound sign at the beginning of each line. Okay, so that's something that you want to be aware of. That's important here, okay? Now, once we've done that, what I want to show you now is some of the types of variables and objects you can create. Generally, you give things a name, and it's going to be case sensitive, a name of a variable that you store data in, either it's a value or a set of values or a whole matrix or something. You're going to give it any kind of name you want. It doesn't matter what the name is. It can be Fred. It can be anything that you want to name, but you have to always be consistent in your spelling and in your case usage, and you don't want to use something that is going to confuse a program you write. For example, you don't want to use probably the word mean or something in case there's a function named mean. You typically want to avoid those, although we can generally figure out from context. Now, you can go ahead and just put equals and tell it what the value is. So this is going to basically put the number 6 into the name Fred, okay? But instead, we typically use this arrow instead of the equals. It reduces some confusion with some types of programming that we might do, and it is the commonly used method, so I'm going to use that. And you just use that less than sign and the dash to create it. So we can put in there just a specific value. Now nothing happens yet because all I've done is write the line in code. I have not run the line of code. If I want to that actually to go in there, then I'm going to hit this run button. Okay? Just click on that line anywhere on the line. Don't just highlight part of it because then it will just be confused and think you just want to run the number 6 and not the whole line of code. So either highlight the whole set of stuff or just click on the line and run it. It's run. Okay? And one thing you're going to find is everything you've done gets stored up in this little history tab up above. Okay? That's all there. And it is a file that you can save and that you can read back in. So if you want to redo what you've done, it's not really necessary when you're saving everything you're doing here in the script file. However, if you haven't, then it is necessary. Okay? And you can clear it all out if you want to there as well. Okay? And if you click on the environment tab, what you're going to see is I have a variable called Fred, and in it is saved the number 6. So it keeps track of those things that I've created in that environment tab there. Okay? So those two tabs may be helpful to you. Now, the other thing we can do besides just saving new numbers in variables is we can save what's called a vector. A vector is just a set of values. It can be, and the same is true as of just something like Fred that has an individual value. It can be a number, or it can be words, which we call character, or it can be true, false. Okay, which looks like character, but it's not handled quite the same way. So let's say I want to make another one. This one is going to be a set of values. Okay, and the way that we create a set of values is we have to use this combine function. You'll notice if you type C and then hit a parentheses one way, it automatically provides the second parentheses for you. It does that so that you can not miss, forget to put the parentheses on the other side. And you'll see things color-coded through it. See, we've got a numeric value. And what I can do is I can just put in a list of values separated by commas. Okay, that's all I can do. And I hit run. And when it's run down below, you're not going to see that it says anything but this. It just copies the whole statement you made. You don't have an error down there, so you know that everything went okay. If I want to look at what is in a particular variable, all I have to do is just type the name of the variable and hit enter down below. So I could just type Fred down below and hit enter. Okay, and it shows the 6. Or I could have it typed up here, oops, right up here within the script file, and just click anywhere in that line. Remember, don't highlight anything unless you highlight it all. Hit run, and it'll show me down below those values. Or I can go and I can just highlight the name of the variable, and if I do, that's equivalent to just typing only that much into the console below. So I hit run, and it's going to show me down below what that variable's value is. Okay, now we're going to try another one, but in this particular case, what we're going to do is we're going to use words, okay? And it can be anything. I'm just putting some nonsense in here. And I have them in quotes. You notice I put them in quotes. Now, this is something to be very careful of. Whenever you have words or something to be treated as character, or words, in other words, you need to put it in quotes. It will turn it green. You need to make sure those quotation marks look perfectly straight. If you have written code in like a Microsoft Office document and copied and pasted here, usually the quotes will look curved. And then you'll get an error and won't do it. You need the quotes to look straight, just like I've got here, not curved, to not get an error. I hit run, okay, and then I can highlight Sam, and I get hi, bye down below. You'll see that I've got those. Okay, so that's some things. And of course, I can do it with just one value as well. anything I want to put in there within quotes, it's going to consider that it can be an entire phrase within the variable named Kate, and I hit run. Okay, and when I just highlight that and run it, you'll see it come out below and so forth. So those are your just basic, again, individual variables, let's call it vector values, linked together or combined with that C function and a comma. Now I can also, if I want to create a vector with a set of numbers in them that follow a pattern, there's often shortcuts. So for example, I can go like that, 1 to 10, okay, and it's going to just go ahead and run that, do it. All right, and then when I run it below, you'll see the numbers 1 to 10. Okay. I can also do things like this. Repeat, that's rep means repeat a value 4 6 times. Repeat the value 4 6 times. And now if I go down here and type in Tom, or I highlight it below and run it, any way that I do it, you'll see you get a 4 6 times. So there's a variety of ways that you can make these vectors a little bit more quickly. Okay. Now, the next type of thing we've got essentially the variables that are just one thing. They can be text, or they can be true false. We haven't done true false, so I'm gonna do that one next. Combine, I gotta add that. And that's gonna have the values true false in it, which will be often treated differently. Okay, I want you to notice the true false turned out blue like the numbers. It didn't turn out green like the character responses. Okay, so we've got something with just one item in it. We've got a vector, which is just like a column or a row of data. It's like got one dimension. And now we're going to go to the two-dimensional, which is basically a matrix or a data frame. Matrices and data frames look the same, but they're different, slightly different. Okay, let's talk about the differences. If you've done any math courses that involve matrices, you might be familiar with a matrix as having rows and columns, and with numbers in it. Okay, a matrix has to be all the same type. So if it's numbers, it has to be all numbers. If it's logical, which is true false, it has to be all true false. If it is character, it has to be all character, every element in it. Okay, and so that's one limitation of a matrix. A data frame is similar, that it has rows and columns, but in a data frame, each column could be a different type. And data frames are used more often. You can do things with matrices that you can't with data frames, and vice versa. Okay, so what we're going to do is we're going to make a new variable. I'll just call it M1 for matrix 1. And you don't know, I by habit put spaces before and after things just to make it more readable. You don't need to do that. There's a couple ways that you can do it. Okay, you can do the matrix command, and when you do the matrix command, you put within the matrix a vector that has all the stuff in it. So if you imagine that you've got it, it lists everything in row 1, then everything in row 2, then everything in row 3, then everything in row 4, and so forth. Okay, so you're going to have that as if it were in a straight row, and then you're going to tell it how to break that up into rows and columns for your matrix. So I'm just going to put some I'm going to put 6 values in there just to make it fairly quick. So it says take all these values, and now what you're going to do is you're going to tell it either how many rows or how many columns you want, and it's going to figure out the rest from that. So I'm going to tell it I want 2 rows. Since there's 6 items, it's going to make 3 columns, of course, right? And then you have to tell it by row equals true if what I want it to do is to read across the first row is 1, 3, 4, and the next row is 5, 6, 7. I tell it false if I want it to be by column. So this is the first row, first column, and then this one goes right under it. The 3 goes right under it. And then the second column is 4, 5, and then the next is 6, 7. So those options help you get it lined up correctly. I just hit enter. And now if I type in M1 down below, then you're going to see that matrix. Okay, so I've got my a matrix set up now with all this data in it. There's a variety of types of matrix arithmetic you can do, but I'm not going to show that in this video. I'm going to probably have a dedicated video to matrices and matrix arithmetic and all the things that can be done with it. Okay, so I've got this matrix set up now with just those values in it. If I want to at any time refer to a particular element in a matrix, like I want it to pull out this number 6 and do something with it, I tell it, I use these square brackets, and I tell it I want the item that is in row 2, column 2. Okay, rows before columns. And if I just run that little line, it's going to pull out the 6. And I can do anything with that. So for example, I can say, you know, I want to put into this particular variable this element out of that matrix. So I can do things like that if it's useful to me. Okay, and I can do the same thing with vectors. So I can ask it for Mario, and in this case, I am selling it the third item in Mario. So get to Mario, it should give me back an 8. I hit run, and you'll see down below you do get an 8. So that's how you pull that out of a vector or a matrix. Now the next thing that I'm going to talk about here is data frames. And data frames, again, are similar to matrices, except that each column can be a different kind of data. And you do have to have them so that each column is the same lengths, so that things match up, like everything in row 3 across each column goes together and so forth. But this is something that'll be really commonly used, like with statistical analyses and things, is that you have to set up as a data frame. And one thing that that you can do is you can, and your data most often for like statistical analyses would be in a data frame, is you can say data.frame M1. What that does is it changes the matrix into a data frame. So now it's a data frame. And now if we look at it, you'll see that it looks a little bit different, okay? What it has now, instead of with a matrix where it just shows the row and column numbers here on the sides, it gives a row number just as a numeral, and it's given default column names. You can create names for your data frame, so I'll probably have a video that gets into doing those. By default, it has given it names, and I can refer to particular things in my data frame the same way as a matrix. Okay, so I can do it like that. Okay, saying I want row 2, element 3, okay, which would be that 7 there. Okay, so you can see that. Or I can do it like this. I can say from this data frame, I want, and then $sign. Notice these things popped up. Those are the names of the 3 different columns. So let's say I want column 3, D1 $column, column 2. So it's going to pull out that entire column. So it'll actually be a vector because it'll be one-dimensional data and have several things in it. I can tell it just to pull out that for me. Or, of course, I can tell it D1 $x2 or whatever I want, and then tell it I want well, it won't have 3 things, it'll only have 2 things, okay? And hit run, and it'll pull out that 6 because it's from this column, x2, taking the second thing, pulling out the second thing. So that's some real basics in terms of creating your introduction to R, and some of the most basic things that you're going to find. You'll hit save here. In other videos I'll get into reading files in, saving things out into files and so forth, and all kinds of other things you can do.